we have n objects. From these n objects, we need to use r objects, right? The condition is n is the largest value, greater than or equal r, right? This is the condition, right? Because from the population is n, right? From the population n, we need to take r number of samples. Just imagine that way. Maybe in statistics, you know what is population and what is sample, right? So maybe up to your O level, right? So you have a subject called statistic. On that you discuss if you have a population, we cannot consider all the population for any analytical task, right? So we are consider only the sample space, right? So we are taking few elements from the population, then we can analyze by utilizing the population with the help of that sample, right? So similarly, here n is a population, r is a sample. Just imagine. So if you have 100 students, from the 100 students, we are taking 10 students, and we need to arrange how many ways we can order the elements, right? So this is the first type. Second type, in the first type, we are not repeat the things, right? Without repetitions, right? Without repeating the elements, without repeating the elements. First type. Second type, n objects, you need to take r objects with repeating, repeat, with repetitions, right? So these are the two things we discussed, right? So with repetitions, without repetitions, right? So from n object, we need to take r object, the same conditions, n greater than or equal r, right? With repeat, with repetitions, right? With repetitions, right? So what is the equation for the first one? So NPR. One way by utilizing the equation NPR. Another way, just we can draw some, let's say if we think about the 4 tracks, right? Let's imagine we have 10 objects. From the 10 objects, we need to arrange 4 objects, right? In a 4 tracks, right? So this is 10 ways, this is 9 ways, this is 8 ways, this is 7 ways, right? So maybe you either you utilize this equation, or you either just think about you have a 4 tracks, 4 running track. First track, we have select 10 different ways. So already we will assign one guy for the first track. Then we have remaining 8 students are there. So the second track we can fill with 9 ways, third track with 8 ways, fourth track with 7 ways. This is maybe utilizing the equation 10p4. Both are getting the same answer, 10 factorial over 10 minus 4, 6 factorial. So it is equal to 10 into 9 into 8 into 7 over 6 factorial. 6 factorial we can remove. So the same answer we are getting. This is one type of question, right? Second type of questions with repetitions. So what is the equation for with repetition? N to the power r, right? By utilizing the n to the power r equation, we can find out with repetition, right? The previous example, we are using different scenarios, right? The with repetition, we can utilize for different scenarios. Let's say with repetition, we are utilized to create some words, right? For example, the application is create words, create words using the same letter again and again. So we can utilize this one, or create passwords we can utilize. N to the power r is the equation. This is one way. Another way, the same. Let's say from the 10 objects, we need, let's say from the 10 letters, just imagine you have 10 letters, 10 different letters given. From these 10 letters, you only use 4 letters. 4 letters with, maybe you can use the same letter again, right? So it means with repetition, right? For the first place, we are using A. Second place also we are using A. Third place also we are using A. With repetition mean again and again use the same letter for different positions, right? So now this position we can fill by 10 ways. Second position also fill by 10 ways. Third position also fill by 10 ways. Fourth position also fill by 10 ways, right? So altogether 10 to the power 4, right? So here n is a 10 letters, 10 to the power 4 letters, right? So both are give the same answers, right? This is how we can find out the permutations, right? Do you have any questions? Up to now, we discussed in the last class. Any doubts or any questions? Any questions? Okay, now tell me, right? Okay, my question is, okay, my question is, right? There is a padlock, right? There is a padlock with numbers, right? So there is a padlock, right? The locking system is based on the numbers, right? Based on the numbers, right? That padlock has a five slots, right? It means there are five different slots. It means five adjustable slots. Let's say, I think you know, right? So this is a padlock, right? In the padlock, we have here one, here one, here one. Likewise, there are five numbers we need to select, right? So all the five numbers are correct, then only it will open the lock, right? So for these numbers, right, we have utilizing 0 to 9, right? Now tell me, by how many attempts, maximum how many attempts you need to find out this, the pattern of the password. Tell me, how many attempts you need, maximum how many attempts you need. Tell me. So there is a padlock with number systems, right? They are number, the chain of number 0 to 9 for all positions, right? So there are five chains. You need to adjust these from 0 to 9, here 0 to 9, 0 to 9, 0 to 9. So how many attempts maximum you need to find out the correct password? Tell me. I'm not directly asking the words, right? So you need to think how we can apply this. Tell me. Hope you can understand my questions, right? Mm, yeah, correct. Someone say the correct answers, right? So what about others? There is a padlock, right? You look at those padlocks, right? So there are some adjustment systems. In the adjustment, the numbers 0 to 9, they have adjustment, right? That is a 5-digit passwords, right? So how many possible uh, attempts? How many attempts you need to check the passwords? So maybe for these questions, right, you can utilize what? Which equations? Which equation you utilize? Tell me. NPR or n to the power r. Which equation you utilize? Which equation you can utilize to find out the answer for these? NPR or n to the power r. What is the reason for that? So this is how we need to understand, right? So you need to think which equation is eligible for this equation, why that is suitable, why that equation is eligible. So this is how you need to learn, right? If I, not only me, whatever the lectures, if they tell something, you need to think which equation is utilized, which equation is appropriate. What about the first equation? So if you are utilizing the first equations, what is the scenario? So if you are, let's say, if you want to utilize the first equation NPR, right? The condition is if you are using one object, we cannot use the same object again, but not the case here, right? So for all that positions, we have 0 to 9, the same 10 digits, right? So the NPR is not eligible. So only the equation is n to the power r is suitable for these. So what is the n here? So n means 0 to 9. So 0 to 9 means there are 10 different objects. N is 10. From this n, how many objects we need to select? So how many positions we have? 5 positions. So 10 to the power 5. So 10 to the power 3, 10 to the power 4, 10 to the power 5, right? 1 lakh, right? 100,000 100,000 times you need to check the passwords if you want to find out the correct password for this padlock. This is one way. Another way, right? So here 0 to 9, right? So the first position we can find out in 10 ways, right? Second position we can find out in a same 10 ways, right? Because the same digits maybe again it's possible, right? The first digit also 0, second digit also 0 possible, no? So likewise, the third digits, third digit, fourth digit, fifth digit, up to all, we have 10 options, right? So keep in mind, I'm not directly asking n objects. You can utilize r objects and find out the permutation, right? I'm not asking find out the permutations, right? I'm giving you a scenario. For that scenario, you need to think about whether it's suitable to apply the permutation or combinations, right? You are the one decide which one is eligible, which one is suitable for that one. How we can find out? For that scenario, either we can give priority for the order or not. Depending on that, we can decide which equation we can utilize, right? So I'm not telling you can use the permutation or combinations, right? So you are the one decide suitable one based on your knowledge. How we can find out the suitable one? If you are giving priority for the orders, then we need to utilize the permutation. If you are not giving priority for the order, we need to utilize the combinations, right? So keep in mind that one, right? So these are the two types we discussed last class, right? Now I will introduce some other types of questions, right? So up to now, you know, two types, right? If we have n number of objects, from the n objects, we are selecting r number of objects and we are creating permutation. We are creating different orders. At that scenario, there are two things possible with repetitions, without repetition. For both, we know how to find out the answers, right? Okay, now the third type, right? Yeah. Give me a minute. Okay. Can you hear me now? Hello, am I audible? Okay, yeah. Okay, now we discussed two types, right? The third type, right? This is the third type, right? I will explain. Just clearly understand. Try to understand clearly, right? So the third type is, just think about, you have n objects, right? You have n objects, right? From You have n objects, right? From these n objects, we need to utilize all n objects. Here this is an example, right? You have n objects. Previous example, from the n objects we are utilizing r number of objects, right? R is less than n, right? So that is the previous scenario. Now you have n objects. Now you need to utilize n objects, right? You need to use all n objects, right? N objects, you need to utilize n objects, right? Among these n objects, right? Some objects are, let's say, few objects are the same objects, right? Few objects are same objects. Let's say, just think about, I will explain with an example, then you can easily understand, right? Just think about, you have n objects, right? From these n objects, we need to utilize all n objects. Among these, let's say, maybe three same objects are there. Three same objects are there, right? Let's say three same objects in the sense. Let's say we have 26, let's say we have 10 letters, right? We have 10 letters, right? We need to use all 10 letters. The condition is, from these 10 letters, three letters are A. A, three letters, right? A occurs three times, right? You have 10 letters, right? Let's say, just think about A, B, C, A, D, A, E, F, G, H. So here how many letters? 2, 4, 5, 6, 7, 8, 9, 10. 4, 5, 5. Altogether 10 letters. A, B, C, A, D, A, E, F, G, H. Right? So here we have 10 different letters, right? From these 10 letters, A occurs three times. One, two, three. Others are only one time occurs, right? So this type of scenario, if you want to utilize all 10 letters and you need to create the words, how many words we can create? How many words we can create? Tell me. Do you know how to find out the answers? So for this type of scenario, right, let's say we have 10 letters, no? So 10 factorial over, right? So A occurs three times. So no, now what will happen? You need to divide it by 3 factorial, right? These number of words we can generate, right? So n factorial over n1 times the same letter occurs, right? So divided by n1 factorial. Okay, now just think about, here there is no G and H. Just think about A, B, C, D, A, B, C, D, A, B, C, A, D, A, E, F. Right here we have two D's are there. Okay, let's say one D and one C. Right. So now also we have 10 letters. Right. So now tell me occurrences of each letter. So now the scenario is different. Right? The same thing we can apply, right? How many A's? We have three A's, right? We have how many C's? Two C's. We have three A's, two C's. Also, we have how many D's? Two D's, right? Three, five, six letters, right? Here, this is same. This is same, right? This is same. This is same. So remaining a one time occurs. Only one B, one E, one F. Right. So now how we can find out? All together we have 10 letters now. 2, 4, 5, 5, 5, 10 letters. 10 factorial over 3 factorial into 2 factorial into 2 factorial. This is how we can find out the answer for this scenario, right? Here what we can do, we have 10 objects. By utilizing these 10 objects, we need to create the words, right? So here what will happen, they are telling some objects are the same objects, right? So if you are using the same objects, what will happen? 10 factorial over 3 factorial into 2 factorial into 2 factorial. Any questions or any doubts? Please let me know. This is the third type, permutation. Did you understand or not? Please someone responds. Otherwise, I take you all understand, right? Definitely you have some. mm which one you understand? We didn't understand. Please let me know, right? Better open your mic and talk, right? Rather than typing the message, right? So if you not understand, please open your mouth. So which portion you didn't understand? Okay, I will explain again with an example, right? Then you can easily understand, right? So, okay, just forget about these, right? Okay, now previously we know, right? There are two types, right? That is clearly understand or not? Let me know. So if you have n objects, let's say you have n objects. Just think about, let's say we have a, okay, yeah, just think about, we have, there are five letters A, B, C, D, E, right? Right? From these five letters, right, I need to create three letter words. Three letter words, right? I need to create three letter words, right? My first questions, without repetition, without using the same letter, without using the same letter again in the word, without repetitions. Without repetitions, how many words you can generate? Tell me, how many words you can generate? Five letters, n is equal to 5, 5p, 3, right? Did you understand why? So 5 factorial over 5 minus 3, 2 factorial. So it is equal to 5 into 4 into 3, right? 60 words we can generate with the repetitions. So how many letters we can make with repetitions? With repetition means, let's say without repetition means we can create a word A, B, C, right? We cannot create a words A, B, A, right? This is called without repetitions. With repetitions means, with repetition means we can create a word AAB, right? This is also possible. AAA. This is called repetitions, right? These are possible words in repetition. So how many words we can create? 5 to the power 3. So 5 to the power 3 into 125 words we can generate, right? 125 words we can generate, right? This is first scenario. The same example, we have five letters. Now we have five letters A, B, C, D, E, right? We have five letters A, B, C, D, E, right? We have five letters A, B, C, D, E. By utilizing all five letters, by utilizing all five letters, how many words we can generate without repetition? My first question, without repetition, without repeat, without repeat, how many five letter words we can generate? Tell me. Without repetition, how many five letter words we can generate? 5p, 5. So 5 factorial over 5 minus 5 factorial, not factorial. So now 5 factorial over 1, right? So 5 factorial is equal to 5 into 4 into 3 into 2, right? 5 into 4 into 3 into 2. So total how many? 120 words we can generate, right? With repetition means 5 to the power 5 number of words with repetitions we can generate, right? I think you clear with these, right? This is the first two scenarios we discussed, right? The third scenario is, right, just think about, we have letters A, B, C, D, E, A, right? So the third scenario is the same letter A occurs two times, right? This is your n number of objects. From this n number of objects, A occurs two times. This is the third scenario, right? So now let's say you have six letters, right? Okay, just think about, I remove the E. Now also we have five letters, right? A, B, C, D, not E. Now we have another A, right? A repeat two times, right? This is the third scenario. Did you understand? So try to differentiate what is the first scenario, what is the second scenario, what is the third scenario. Then only you can easily understand or then easily remember how we can create the equations, right? So this is the third scenario, right? You have n number of objects. Among these n number of objects, some objects are the same objects, right? Same objects in the sense, right? Just imagine you have five, let's say you have five cards, right? Same size, five cards, right? In the previous two example, one card contain A, another card contain B. Okay, up to now we discuss we have five cards, right? Just think about, we have five separate cards, right? Here I can write all together in the same, right? The actual case there are five cards, one card A, one card B, one card C, D, E, right? So by utilizing five different cards, but all the cards are with the same size, but they are written as different letter, right? This is the first scenario, right? First two scenarios, this is the condition for first two scenarios, right? So if you can take a piece of cardboard, you can write same size five cards. You can put the letters A, B, C, D, E. Then let's say first scenario without repetition means, right, how many positions, let's say if we take one card, then we can keep that card and we can put another, we can take another second card, keep that card, take the third card likewise. With repetition means we are taking for one card, again we can put the card inside the box, take another card, again we can put the card inside the box, take another card. This is the scenario, right? Now the third scenario, right, we don't have the first two scenarios, each letter is a unique different letters, right? We have a five cards, five different cards, five different values are written in the cards, right? Now the third scenario, some cards we are writing the same letter. That is the thing. Let's say now we have a five cards, right? Two cards they contain letter A, right? So the two cards they are containing the letter A, right? Remaining three cards different letters, right? Now the type of question is, we have five cards, right? By utilizing these five cards, we need to create, right? By utilizing these five cards, we need to create different words. How many words we can create? For this type of questions, we are not consider repetitions, right? So without repetitions, we think about, right? So how many words we are creating without repetition in the sense, right? Definitely we cannot apply NPR or n to the power r. Why we cannot apply these two? The letters are repeating, right? The letter A repeating two times, right? So this type of questions, first thing what we need to do, occurrences of each letter. So the letter A occurred two times, all other letters are occurred one time. B is one time, C is one time, D is one time, right? So this type of scenario, how we can find out how many words we are generating, the specific equation. Altogether, we have n letters, one, two, three, four, 5 letters over that more than one time occurring letter for that factorial we need to divide, right? 2 factorial, n factorial over 2 factorial. So here n is 5 factorial over 2 factorial. 5 into 4 into 3 into 2 factorial over 2 factorial we can cut down. So here 5 into 4 into 3, 60 words we can generate, right? So this is the third scenario. Did you understand or not? Please let me know whether you understand or not. Okay, I will explain again with an example, then you can easily understand, right? Mm, I don't know why you are doing this more silent, right? This is not a good way, right? I don't know why you are doing this type of bad manners, right? So please let me know, right? Even I can cancel the lectures, but I don't like to cancel. That's why I am putting as online mode, right? Don't practice the same way how your seniors are behave, right? That's not a good thing. Okay, then I will explain with an example again, then try to understand, right, what I'm telling. Right, first you can read these question, right? Try to understand this question, right? Okay, just okay, yeah, this is the third type, right? Just read this example, right? Okay, just read this paragraph, right? Just read this paragraph, then I will explain. This is the third type, right? We indicate the proof of the above theorem by particular example, right? Now, what is this example says, right? They want to generate 5 letter words, right? So this question says they want to generate 5 letter words, right? 5 letter words they want to generate, right? They want to generate 5 letter words, right? So using the letters, they want to generate 5 letter words by using the word letters from the word baby, baby, B-A-B-B-Y, right? So here they are giving one word. By utilizing the letters of these word, you need to create 5 letter words, right? So how many letter words you want to create? 5 letter words, right? You want to create 5 letter words. For that purposes, you are using these letters, right? B-A-B-B-Y. These are the letters you need to use, right? You have a letters B-A-B-B-Y. By utilizing these 5 letters, you need to create 5 letter words, right? How many 5 letter words we are creating? If each letter is a unique, different letters, that is a different scenario, right? Each letter is a unique letter. Each letter is a different letter. That's a different scenario, right? NPR, we are utilizing the NPR, right? Without repetition. With repetition, n to the power r, right? Maybe this example, they are telling, we indicate, yeah, they are telling yeah. Suppose we want to form all possible 5 letter words using the letters from the word baby, right? So now, okay, now tell me, let's say now we will take this is a B1, right? We can maybe we can separately indicate this is a B1, right? We can separate okay, we can separate this way. B1 A, right? This is second B, B2, right? This is a third B, right? This is Y, right? Now just think about this is are the five letters, right? Now just think about, okay, we have separate B1, B2, B3. Now tell me how many words without repetitions we can make. Without repetition, how many words? Now just think about B1 is a separate letter, B2 is a separate, B3 is separate. Altogether we have five letters. From these five letters, we need to make five letter words. So NPR is the equation. Why we are using NPR without repetitions? Because also we have considered B1, B2, B3 as a separate letters. So 5 factorial over 5 minus 5 factorial. So 5 factorial is equal to 5 into 4 into 3 into 2. So 120 answer. Not factorial is 1. So 120 is the answer when B1, B2, B3 is separate letters. But the problem here, all three letters are B. So it means maybe either you are using the first B or second B or third B. We consider, let's say, okay, just look at here, this example, right? So this is when all 120 words we can make when each letter is a unique letter. But here they are telling, right, B A double B Y, right? Now just think about this is your one word, right? You are making this is a as a word, right? This is as a word, right? This is one word we are making by utilizing these, right? Okay, just B1, B2, B3. Okay, another guy, right? He can make the same word. This is one B. This is a second B. This is a third B. This is also possible, no? Did you follow what I'm telling? First B, he keep the first B. Here he can swap the B. Second B, sorry, I'm writing the same, right? Third B, here, second B, right? But if you look at these two, both are same, no? So if you internally note down B1, B2, B3, then only we can find out. But the B is the same, right? The same B occurs three times, right? So it means here B1, B2, B3. So the next word that guy make this way. Here second B 1 3, second B 3 1. Another two words B3A BBY B1 2, right? B3A B2 B1Y, right? Now just look at these six letter and tell me all are making the same words, right? All are making the same words, right? So this is one example, right? So let's say just forget about these one, two, three. All are indicate the same word, right? Did you follow me? So this is why we are, let's say, 5 factorial divided by 3 factorial. Why we are divided by 3 factorial? These six words are the same words we are indicating. The reason is because of this B occurred three times, right? The same B occurs three times. That is the reasons, right? These six words are indicating the same word. Did you understand? Hello? It's okay, right? For it's not impact for me, right? So now just think about so just forget about these, right? If I remove all these, the identification of that B, whether first B or second B or third B, all these words are indicating the same word, right? Why it happened? We have three B's, three same B's, right? All are the same objects. So that's why while we are creating n number of, by utilizing n objects, among these n objects, three objects are the same objects. We are divided by three, right? This is why we are. So now by utilizing these letters, so here how many uh, three letter words, let's say how many five letter words we can make, how many five letter words we can make, how many five letter words, 5 factorial over 3 factorial. Why we are consider as a 3 factorial? So what is mean by 3 factorial? 3 factorial mean 3 into 2 into 1, it is equal to 6. So the reason of these 6 is these 6 words are indicate the same word, right? Why we are telling, let's say we have a B1, B2, B3. Let's say if we have a three objects, B1, B2, boy 1, boy 2, boy 3, right? How many different ways we can swap these? How many different ways we can swap these? 3 into 2 into 1, right? Now here also we apply the permutation techniques, right? So the first position, 3 ways, second position, 2 ways, third position, 1 way. So 6 ways we can swap these, right? That is happen internally here. That's why we are divided by 3 factorial in this equation, right? So the third scenario, the letters are repeating the letters. If the letters are repeating, this is the way how we can find out the answers. N factorial divided by maybe R factorial, right? So N1 factorial, right? Hope you can understand now, right? Okay, I will explain with another example, right? Then try to understand. Okay. Mm. Okay, now they are telling one another example, right? Okay, what they are telling, just try to find out the answer for this. Find the number of M of 7 letter words, right? Now you need to make 7 letter words, right? You need to make 7 letter words, right? You need to make 7 letter words. You need to make 7 letter words, right? You need to make 7 letter words that can be formed using the letters from the word benzene, right? They are telling a word benzene, Benzene, right? Altogether, we have 7 letters, Benzene. Altogether, 7 letters. By utilizing these 7 letters, how many words we can generate? This is the question, right? Tell me what is the answer for this. Tell me. Just do it and tell me the answer. What is the answer for this? how we can write the answers, right? They are giving 7 letters Benzene. The important thing here you need to identify, right? Some letters are duplicating, right? Some letters are duplicating in this word, right? So now what if the letters are duplicating? What we can do, we need to find out how many letters are duplicating. So here we have only one B, right? But we have how many E's? One, two, three E's, right? How many N we have? How many N we have? Here we have three E's. How many N's? One, two N's, right? Others are unique, one B, one Z, right? So now, how we can find out the answer? We have 7 letters. In the word of benzene, we have 7 letters, right? Now they are telling you need to use the words, you need to use the letters of this word benzene, right? You need to make 7 letter words, right? So if they ask you to make the 7 letter words, right? Now how we can find out? N factorial over n1 factorial into n2 factorial into n3 factorial up to nr factorial. These n1, n2, n3 up to nr are the number of times each word, each letter occurs the same letter, number of time that same letter occurrences, right? So this is the common equation, right? For this question, what is the equation? So we have 7, we need to make 7 letter word. So just you can write 7 factorial. Why we are using 7 factorial? Let's say if you have 7 unique letters, let's say if you have 7 unique letters, we are making the words 7 factorial, right? Now how many words occurred same time? E 3 times occurred, so we can divide it by 3 factorial. Again we can divide it by 2 factorial. Now what is the final answer? Tell me the final answer.
420.
420, sir.
Yeah, yeah. Some of you are telling the correct answers, right? Yeah, 7 factorial over 3 factorial into 2 factorial, right? So it is equal to 8. 7 into 6 into 5 into 4 over uh, 3 factorial. 3 factorial we can cut down. 2 factorial means 2, right? So if you cut down these 3 times, right? 21, 21 into 20, 420 different words we can generate, right? This is the third type of questions, right? Hello? Yeah, sorry for that interruption, right? Students continuously calling regarding their Viva, right? Okay. Okay, that is the third type, right? So first type, n unique objects. First two types, we have n unique objects, right? The third type, this between n objects, some objects are the same objects, right? So for that one, n factorial over n1 or n2 factorial. Likewise, we can find out these type of questions, right? Okay, this one also we discussed, right? N to the power r. We already discussed this type, right? So this is our second type, but here they are explaining as a here, right? So we already discussed, right? We have a n objects, right, with replacement, right? Sampling with replacement in the sense again and again we are using the same letter, right? So that is we can they are explaining by here n to the power r we discussed, right? So these are the first two types, right? We already discussed these, right? Sampling without replacement, NPR, n factorial over n minus r factorial. NPR is equal to n factorial over n minus r factorial. This is already discussed without replacement. With replacement, we discussed n to the power r, right? N to the power r, right? They are explaining here, right? So now altogether we discussed three types, right? Now we will look at some examples, right? For before moving to the combinations, right? We will look at some examples, right? Okay, just look at this example, right? Okay, just don't look at the answers, right? Just read the question, right? Just read the question. Okay, what is the question they are telling, right? This is the question. Just read. Three cards are chosen one after the other from 52 card spec, right? So we have a card spec, right? Inside the card spec, 52 cards are there, right? So you know the card spec, 52 cards, right? Uh, we have four types of cards, right? Diamond, heart, spade, another one clubs or something, right? Yeah, there are four types of card. This is the diamond, red color. This is heart, right? Spade is something. Club also. Uh, Likewise, this one, right? We have four different types of cards. Each has a 13 cards, right? 13 cards, right? So I think most of you are familiar with the card spec, right? 52 cards. There are four different types: heart, diamond, spade, clubs, and they are numbered KQJ, KQJ, I think up to A. Here A, then 1, 2, I think 1, 2, 2, yeah, 3, 4, up to 9 or 10, right? I think A, 2, 3, 4, 5, 6. Likewise, it will numbers as a 10, right? Here altogether 13. Likewise, they are numbered, right? So I think you all are familiar with the card spec, right? Anyone need to explain or not? Please let me know. Otherwise, I will explain. I think most of you are familiar with the card spec, right? Am I correct? So most of the combination questions they are utilizing card spec, right? Hope everyone aware the card spec. Am I correct? Am I correct? Or need to explain? Please respond quickly. Am I correct? Okay, then no need to explain, right? So now you know how you have a card spec. Each type of cards, we have 13 cards, right? So four different shapes. I explained here, right? The question is, three cards are taken. Just think about there is a box is there. Inside the box, we are shuffle all the 52 cards, right? Now we need to take three cards one by one. We can take first card, then we can take the next second card, third card. Likewise, we need to take three cards among the 52 cards, right? Now the question is, the first questions they are telling without repetitions, right? Sorry, with replacement in the sense, from the box we are taking first card, right? Then again we will put the card inside the box and take the second card. Again we can put the second card inside the box, we are taking the third card. That is we can call with replacement. Hello, hello. Selamun aleyküm. Selam. Om sir, சொல்லுங்க sir. Oh, okay. Just look at here. The first question with replacement and without replacement. Now they are telling, right? Let's say now if you from this card spec, we need to take three cards one after the other with replacement, right? So now they are asking how many different ways you are taking these three cards. It means how many different combinations we are taking with replacement, also without replacement. This is the question, right? How we can find out the answer for this? Tell me. Tell me how many different ways. It means how many different patterns we are creating these three cards. It means first card is a diamond specific number. Second card is maybe hard specific number. It likewise how many total number of different patterns or different three cards we are making. So this is what we need. Maybe this type of questions we apply in the probability as well, right? So let's say probability in the sense, right? The probability in the sense, let's say probability is equal to total number of possible, let's say the sample space over that particular event, right? Hello, sir. Home, sir. Okay, sorry for the inconvenience, right? Okay, normally the probability is uh, first we will find out how many possible sample space even over particular event, right? How many times that event occurs. Let's say uh, if I shuffle a dice with numbered 1 to 6, the probability of odd numbers, the probability of odd number uh, probability of odd number is equal to the sample space. There are six event 1 to 6, right? 6 over odd numbers 1, 3, and 5 are odd numbers, right? There are 1, 2, 3, three events, right? The probability is 3 over 6. It means 1 over 2, 50 percentage. The probability we are getting odd numbers. This is how we can find out, right? The 6 is the total sample space, right? So this question also they are telling the sample space, right? If you have a card spec, right? On that card spec, if you take three cards one by one, the sample space they are asking. So what is the number of different elements in the sample space? That is the question, right? So how we can find out the answers? Already you know with repetitions, right? So first they are asking with repetitions. If I want to take three cards, how many possible ways we can take? So it means I need to take the first card, second card, and third card, right? So the first card I have 52 ways, right? Second card also 52 ways. Why? With repetition. If I take one card, again I can put the card inside the box and I will take the second card. With repetition means that is the meaning of that one. Again, I can take the third cards. With repetition means 52, right? So 52 to the power 3 times is the occurrences of this event, right? Second question, without repetitions. It means I take one card, I can keep the card outside, I can take my second card. So now this scenario, what will happen? Second scenario, right? First position we can fill by 52, but the second position we can fill by 51 times. Third time position we can fill by 50 times, right? This is the answer when without repetitions. Hope you can understand, right? Am I correct? So in permutation, we discussed three different types. Without repetition, without repetition, NPR, right? With repetition, n to the power r. But the third situation, n number of objects, the same objects, then n factorial over maybe n1 factorial divided by n1 factorial. Let's say if you have n objects, n1 number of objects are the same objects in the sense n factorial over n1 factorial. These are the three types we discuss in the permutations. Anyone have any issues or you can understand clearly? So this that's all about the permutation, right? There are a lot of things, right? I give the very basic things, right? Explain very basic three scenarios with you guys, right? This is about the permutations, right? The next one, combinations, right? So the permutation in the sense we are giving priority for the order of the elements, right? combination in the sense we are not consider the order of the elements on we are not give the priority for the order, right? AB and BA we are consider as the same. That is the combinations, right? If you have a n number of objects, from this n number of objects, let's say if you have a n objects, you have n objects. From this n objects, we need to take r objects and we need to generate the combinations. Generate the combinations. The condition is n greater than or equal to r, right? Always we need to keep this way. We cannot say n less than r, right? If it is n less than r, we cannot apply this equation. Keep in mind, right? N greater than or equal r, definitely we need to maintain, right? You have n number of objects. By utilizing r objects, we need to create combinations, right? So now they are not telling whether you can apply the combinations or permutations. Based on the scenario, question scenario, you need to find out which one we can utilize, whether we can utilize the permutation or combination, right? How we can find out the suitable one, whether they are giving priority for the elements or not. If they are giving priority for the element, that questions comes as a permutation questions. If they are not giving priority for the elements, we are considered as a combination questions, right? So let's say now just think about in your classroom, you have 100 students are there, right? 100 students are there. 100 students are there. From these 100 students, I need to take five students. I need to take five students to participate in an event, right? Your population is 100 students. From these 100 students, I need to take only five students to participate in an event, right? How many possible ways I can make this group? Tell me. That is a question. That is we can call combination questions, right? Let's say if you order the students, right, S1, S2, S3 up to S100, right? Just think about I'm identifying each student as a S1 up to S100, right? Now, if I make a student group S1, S2, maybe S3, S4, S5, right? This is my group, right? Also, I can make S1, S2, S3, S5, S4, right? In permutation, we consider this is a separate permutation. The separate one, this is a separate one. But in combination, we consider these two are the same group. Why? Why we are consider these two are the same group? Because the students are allocated this group S1, S2, S3, S4. This one also S1, S2, S3, S4, S5. Maybe S1, S2, S4, S3, S5. So this one also the same group, right? So what I'm telling here in combination, right? We only consider these both the same. If you write this way, this is and this these two are same group we are denoting, right? So that's why I'm telling we are not give the priority for the order of the elements in the combinations, right? Now, how many ways we can find out if you have n objects, here n is equal to 100, we need to select r objects and we need to create the combination. Then the equation says ncr, n factorial over n minus r factorial into r factorial. So if I apply these here, 100c5, 100c5 means 100 factorial over 100 minus 5, 95 factorial into 5 factorial. So the answer is 100 multiplied by 99, 98, 97, 96 over 95, 95 factorial. We can divide it 5 factorial, 5 into 4 into 3 into 2 into 1. So this is the answer for this permutation, sorry, these combination questions. Did you understand? Hope you can understand, right? Hello. If anyone have any issues, please let me know, right? This is we can call combinations, right? So while we are making some groups from the students or from the employees, right, we are not give the priority for the elements. But let's say if you arrange specific number of students in a particular table, we are give the priority for the elements, right? So the order of the elements plays a major role, right? So on that type of question we consider as a permutation. This type of questions we can say as a combinations, right? So now what they are telling, right? Just look at this example. Find the number of combination of four objects. Okay, I will explain with one example. Okay, we will discuss, right? Uh, yeah, I will explain with this example, then you can easily understand, right? There are four objects A, B, C, D, right? There are four objects A, B, C, D, right? From these four objects, right, we need to take three objects, right? So let's say there are four students are there. From these four students, we need to create three student groups, right? So let's say we need to take three students group. We need to take three student groups for a competition, right? So how many possible ways we can make this group? That is a question, right? So how we can find out the answer for these? Let's say we have n is equal to 4. We need to take r is equal to 3, right? From four objects, we need to take three objects for a competition, right? Now tell me what is the equation? 4c3, right? 4 factorial over 4 minus 3 factorial, it means 1 factorial into 3 factorial, right? So 4 into 3 factorial, we can divide it by these two. So four different groups we can make, right? If we have a four students, from these four students, only we can make four groups with three students, right? So I will write all these four groups, right? Let's say A, B, C as a one group, right? A, B, D as another group. A, B, C as a one group. A, B, D as a one group, right? Then B, C, D as a group, right? BD, BCD as a one group, then CDA. So these are the four unique groups we can make, right? So we cannot create any other groups, right? A, B, C as a one group, A, B, D as a one group, B, C, D one group, C, D, A is another group, right? If you can you tell me any other groups except these four, right? These are the four groups we are making by utilizing the set of students, right? Anyone? Can you tell me some other groups? You can't, right? So if you make any other groups, that groups also under these four groups, right? Maybe sometime, let's say someone says CBA, right? But if you think about CBA, already this is exist, right? maybe CDA. CDA, just look at here, CDA, this group, right? So what I'm telling, these two groups are indicating the same, right? Only the order is different. But if you think about the combinations, we are not give the priority for the order of the elements, right? So all together we are creating these four groups, right? So just nothing, we are not giving the priority for the order of the element, that is we can call combinations, right? So this example, right? Okay. But if you think about these four elements, A, B, C, D, if I ask you, I need to create three letter words without repetition in the sense, we can apply 4P3. So if it is a permutation, let's say there are four letters A, B, C, D, we need to create three letter words without repetition, 4P3. So 4 factorial over 4 minus 3, 1 factorial. So it means 4 factorial, 4 into 3 into 2 into 1, right? Then 60 words we can make, right? So we have four letters by utilizing three letters without repetition, not with repetition, without repetition, we can 4p3, 4 factorial over 4 minus 3 factorial, 1 factorial. So altogether 4 factorial times we can generate the words. So 4 factorial in equal to, sorry, 24 words, right? So I did a mistake. 4 factorial in the sense 4 into 3 into 2 into 1. So it is equal to 24 words we can make, right? So these are the all 24 words maybe we are making, right? This is permutation. But if you think about the combinations, 4C3, 4C3 is equal to 4 factorial over 4 minus 3, 1 factorial into 3 factorial. So 4 factorial over 3 factorial we can cut down. So it is equal to 4 words, right? Even if you look at these 24 words, only we can take these are 4 words, right? So if you look at the first row, if you look at the first row, A, B, C, only this is the group, right? All the 6 combinations, they are include only A, B, C. These are the 3 objects. If you look at the second one, all these 6 permutations indicate the 3 letters A, B, D. If you look at the third one, only object A, C, D is indicate among these 6, right? If you look at the B, C, D, only these B, C, and D included in these 6 permutations, right? So now this is the relationship between the permutation and combinations, right? Any questions? Any questions? Okay, if you don't have any questions, we will move for the exercise. Okay, now I will explain with an example, right? Just read this question. Okay, just read this question. Just read the question first. Okay, hope you can read the question, right? So let's say a farmer has some number of animals, right? A farmer in his garden, there are 6 cows, right? 5 pigs and 8 hens, right? So altogether, he has how many animals? 19 animals, right? 19 animals in his garden, right? Now, what he can do, he need to sell some animals, right? So from these 6 cows, he need to sell 3 cows and 2 pigs and 4 henses, right? So from these total number of animals, he need to sell 3 cows, 2 pigs, and 4 henses, right? So now the question is how many possible options he has to sell these animals. It means he has a 6 cows, no? So from these 6 cows, he need to sell 3 cows. So how he can select these 3 cows? What are the different possible ways he can select these 3 cows? Tell me. So the question is the farmer buys a farmer, sorry, not selling, right? He need to buy, right? So, oh yeah, sorry for that. A farmer buys 3 cows, 2 pigs, and 4 hens from a man who has 6 cows, 5 pigs, and 8 hens. Find the number of M choices that the farmer has, right? Let's say he visited uh, he visit a particular man. That man has 6 cows, 5 pigs, and 8 hens, right? From these, that particular farmer need to purchase, that particular farmer need to buy 3 cows, 2 pigs, and 4 henses, right? So what are the possible combinations that farmer has, right? How we can find out the answer for this question, right? First thing, we need to find out how many possible ways that farmers select the cows. Tell me, how many possible ways that farmers select the cows? How many possible ways the farmers select the cows? How many possible ways farmers select the cows? What is the equation for this? So now you need to think whether it's coming under permutation or combination. There are 6 cows. We need to buy 3 cows. So we don't worry about which order we are selecting. We only consider what are the cows we are selecting. Among these 6 cows, we need to select 3 cows, right? What are the different combinations we have? We are not giving the priority of the cows, right? First, we are selecting this cow. Second, we are not consider that way, right? We only think about among these 6 cows, what are the different combinations we are selecting those 3 cows. So what is the answer for these? Altogether we have 6, maybe similar to that one. There are 6 students. We need to select 3 students for a competition, right? Similarly, here we have 6 cows. From the 6 cows, we need to select the 3 cows, right? So the answer is 63P. So it is equal to 6 factorial over 6 minus 3, 3 factorial into 3 factorial. So 6 into 5 into 4 divided by 3 factorial we can cut down. 3 factorial, another 3 factorial is there. 3 into 2 into 1. So 3 into 2, 6. Here we can cut down 6. So 5 into 4, 20 ways we can select the house, right? Now the next thing, we need to find out how many possible ways we are selecting the pigs. So how many possible ways? Altogether we have 5 pigs. From these 5 pigs, we need to select the 2 pigs, right? So 5C2. So 5 factorial over 3 factorial into 2 factorial. So 5 into 4 into 3 factorial, 3 factorial. 2 factorial is divided by 2. So then 10 ways we are selecting the pigs, right? 10 ways we are selecting the pigs, right? The third one, how many ways we are selecting the hens? 8 hens. We need to select the 4 hens. 8C4, 8 factorial over 8 minus 4 factorial into 4 factorial. So then we can say 8 into 7 into 6 into 5 into 4 factorial. 4 factorial we can cut down. 4 into 3 into 2 into 1. So we can cut down, this is 6, this is 6, right? Then here 4, here 1 time, here 2 time. So 2 into 7 into 5. So 7 into 10, 70 ways, right? So now we are individually consider how many times each animal we are selecting, right? So now the question is how many total ways they are selecting all animals. So how total m ways in the sense we need to take the multiplication of 20 into 10 into 70. So it is equal to 20 into 700, then sorry, 20 into 700, then it is equal to 14,000 ways we are selecting these animals, right? So this is the answer for these questions, right? So maybe you can directly write the answer in a one line, right? How 6C3 multiple by 5C2 multiple by 8C4, right? So even if you find out this one also, you are getting the answer as a 14,000, right? This is how we can find out the answer for this type of combination questions, right? Hope you can understand this example, right? Okay, now we will move for the some exercise questions, right? So now I cover most of the theory part, right, in this. Right now we will move for the applications or practical questions, right? Yeah. Okay. Yeah, I think you know, right, how to the first one, right? So 4 factorial, 4 factorial means 4 into 3 into 2 into 1. 5 factorial means let's say 4 factorial means 4 into 3 into 2 into 1, right? That is equal to 24. 5 factorial means we can write 5 into 4 factorial. So 4 factorial we can write 5 into 24, that is equal to 120. Likewise, we can find out the answers for the first few questions, right? So I don't need to explain for all, right? So you can do it this as a homework, right? uh, yeah, the next one, 13 factorial over 11 factorial. So how we can simplify these? 13 factorial we can write 13 into 12 into 11 factorial. Below we have 11 factorial, we can cut down this one with this. So 13 into 12 is the answer for these, right? So likewise, 7 factorial over 10 factorial also we can write 7 factorial uh, divided by 10 into 9 into 8 into 7 factorial. 7 factorial, 7 factorial, we can cut down 1 over 720. 9 into 8, 72 into 10, 720. 1 over 72 is the answer. This is how we can simplify these type of equations, right? So I don't need to explain much more about these, right? So you can, yeah, up to these, you can do it as homework, right? These are nothing, very simple thing, right? Up to these you can do it as a homework, right? Okay, I will explain with some questions, right? Counting principle questions, right? This is, I think, let's say, okay, yeah, just read this question first. Just read this question first. There is a bookcase shelf. There is a bookshelf is there. It contains 5 history books, 3 sociology books, and 6 anthropology, and 4 philosophy books, right? So altogether 5 into 3, 8 into 6, 14, 14 into 4, 18 books are there, right? Now the question is find the number of n ways a student can choose one of the textbook, right? So altogether there are 18 books. From these 18 books we allow only one book can be chosen or picked by a student. So how many ways? 18 ways, right? If we have 18 books, we allow only take one books, only 18 ways he can select the book, right? Now they are telling one of each type of books, right? Here, how many types we have? 5 history books are there, 3 sociology books are there, 6 anthropology books there, 4 physics, psychology, sociology and psychology books are there. There are 4 types of books we have. Right now, they allow only one book from each category. Right now, tell me how many ways that students select from the history book? 5 ways, right? Now, from the sociology book, 3 ways, multiple by 6 ways, multiple by 4. These number of ways he can select these books, right? So 5 into 3, 15, 6 into 4, 24. So altogether, 360 ways he can select the books, right? If I ask you to take one book, these are the ways, 18 ways he can select. If I ask you to select one book from each category, what will happen? There are 5 history books are there. Maybe that guy select the first history book and first sociology book, first anthropology book, first psychology book. Also, sometimes he can select the first history book, first sociology, and first anthropology books, but he has second psychology, third psychology, fourth psychology. Likewise, we have altogether 360 different possible combination. He can select the 4 books, right? Did you understand? Please let me know if you can't understand, right? Open your mouth, otherwise I can't understand, right? Definitely use trouble in your final exams, right? Try to understand those things. If not, maybe you lose your marks in your final exams, right? That's the thing happen. Nothing will impact me if you keep silent here, right? Keep in mind that one. Okay, the next question. Okay, just read the next question. A history class contain 8 male students and 6 female students. In a class, 8 male students and 6 female students are there. Find the number n of ways that the class can elect one class representative. Okay, the first question, one class representative, 2 class representatives, one male and one female. The first question, right? There is a classroom, 8 male students and 8 male and 6 female students are there. Altogether, 14 students are there. The first question, we need to select only one, the first question, the A, they are telling we need to select a class representative. It means we need to select one class representative. So how many possible ways we can select? 14 ways, right? So if you have a 14 students in your classroom, 8 male and 6 female, there are 14, 8 plus 6, 14, right? So 14 ways you can select your class representative, right? Either 14, if you have 14 students, among these 14, you're selecting one students, right? So altogether you have 14 ways you can select your class representative. That's the thing, right? Did you understand the first question? So we are selecting one class representative in 14 ways. Did you understand? Okay, if you are don't talk, it's okay for me, right? I will explain and I will stop the things, right? Okay, the second one, okay, the question number two, 2 class representative, one male and one female. We need to select one 2 class representative, one male and one female, right? So now they are telling among these 60, 14, 8 male and 6 female, we need to select one male representative plus one female representative. Now how we can find out? So now let's say the population is 8 male students and 6 female students, right? Among these 8 male students, we need to select one, right? Among the 6 female, we are selecting one, right? Now what will happen if you want to select the class representative of two with one male and female? How many possible ways? How we can find out? If you are selecting one or maybe n number of people from a group, right? Normally we apply the not permutation, we apply the combinations, right? So from 8 male students, we need to select only one. Then we need to take the multiplication. Why we are taking multiplication? We are not taking the additions, right? So why we are taking multiplication? Let's say if I select from 8 male students, so let's say I will explain. I'm writing, let's say female as a F1, F2, F3, F4, F5, F6, right? If I take the male one, with this male one, I have on altogether how many possibilities? With male one, male student one, I have how many possibilities? 6 possibilities, right? 6. Similar to male 2, I have 6 possibilities. Male 3, I have 6 possibilities. Likewise, if we have 8 males, 8 times 6 possibilities. That's why we are taking 8 into 6, 48, right? So we are not taking the addition. Here we are taking multiplication. That is a product rule, right? I already explained. So now here, from these 8 male students, we are selecting one male representative in 8C1 ways. Here we have 6 female students, 6C1. So this is the answer for these. So 8C1 is equal to 8 factorial over 8 minus 1, 7 factorial into 1 factorial, 7 factorial into 1 factorial multiple by 6 factorial over 6 minus 1, 5 factorial into 1 factorial. So 1 factorial we don't need to write. That is equal to 1, right? So 8 into 7 factorial we can cut down. 6 into 5 factorial we can cut down, right? So now the answer is 8 into 6. 48 different ways we can select the student groups, right? So this is they are explaining here. Third question, one president and one vice president. So the third question, among these 8 male students and 6 female students, one president and one vice president, right? Now they are telling any the gender differences, right? Among these 14 students, right? Among these 14 students, we need to select one president and one vice president, right? Now tell me how we can apply for this one also. We need to apply the combinations, right? We are not consider permutation. We need to apply the combinations because we are selecting a group of people, right? So now for the president, how many ways I can select? 14C1, right? 14C1 is the ways, how many ways I can select the president, right? Now, how many ways I can select the vice president? If I put 14, is it correct? 14C1. Tell me. Okay, I will stop the explanation of the exercise questions, right? So you can do it yourself, right? I will start the next slides. Okay, next chapter, right? I will stop the explanation by here, right? Okay. So here what will happen? 13C1. Why I am consider 13C1? Already we select one student for the president. So we have remaining only 13 students. So 13C1. So answer is 14 factorial over 13 factorial into 1 factorial. 13 factorial over 13 minus 1, 12 factorial into 1 factorial. So here the answer is 14 into 13, right? So this is number of ways we are selecting the president and vice president, right?